CIMP-3D was formed in 2012 under initial DARPA funding under the Open Manufacturing Program. And we were defined and selected from a very competitive award process to be DARPA's additive manufacturing demonstration facility for the Department of Defense.
So CIMP-3D has been around about 5 or 6 years now. We've been dabbling in or using 3D printing for 20 plus years, but really in the last 5 or 6 with CIMP-3D, we've been able to deep dive into metal 3D printing.
We've seen a lot of metals research because people understand that plastics, you can design all these things and have them fairly quickly, but they don't withstand stresses like the metal parts do.
One of the benefits of 3D printing that you can manufacture shapes and funky geometries that you maybe can't manufacture using any other conventional means.
To be able to use lightweight materials, use lattice structures that you couldn't possibly do in subtractive manufacturing. You really have to have this additive capability to get structures that we really haven't conceived the ability to use before. And that's probably one of the most exciting things.
The Navy, among others, is trying to figure out, how do we really use 3D printers on our ships, bases, whatnot, for repair, refurbishment, new parts.
We have a very strong effort and emphasis in the training at the graduate, undergraduate, and workforce development levels.
It's a place for industry to come and see the equipment and see it working, to receive training, to send their employees for training as well. It's a very kind of multidisciplinary facility, and it's because additive manufacturing is a very multidisciplinary type of field. It's industry, academia, and also government. All of those groups are trying to understand the capabilities of all of this different equipment, trying to understand the processes.
CIMP-3D brings in a lot of industry people and government people to take their hands-on training classes. Now there's new opportunities in terms of new designs that can be done because of 3D printing. I think there's a real role for ASME in this space. Every gas turbine manufacturer is a little bit afraid to put a printed blade into a spinning engine. There's a lot of work in terms of certification to be done there, and I think ASME can play an important role there.
This is a great opportunity for the academic world and the industries to work together, hopefully to accelerate the development of standards to match the speed of development here in advanced manufacturing. ASME and Penn State both can have a great part in that.